In this friction problem, we're going to be looking at a box on a flat surface, and we're going to investigate both the slipping and tipping that could occur. Okay, so in this box we've got a 4-foot high box. It's 2 feet wide, and it weighs 100 pounds. And it is subjected to a force on the left at the halfway point, so 2 feet off the ground. And the first thing we want to do is we want to calculate what is the force necessary to make it slip. Okay, in this case we have a static coefficient of 0.40. So let's go ahead and draw the free body diagram of this box. Okay, and so we have the box, we have the weight, 100 pounds in the center, force applied 2 feet off the ground, the normal force acting in the center of the box. Okay, and that also we have, since it's a force being applied left to right, we're going to have a force on the right side going left, and that's the friction force, which opposes that applied force. The normal force here will equal 100 pounds. Okay, that's just simply a summation of forces in the y. And the friction force here is going to be equal to the 0.4, the coefficient of friction, static friction, times the normal force, so that it equals 40 pounds. And if we do a summation of the forces in the x direction, we get the force necessary to cause this to slip is 40 pounds. Next, we want to check to see if this box will actually tip. Okay, because if it tips before it slides, then you're gonna have a tipping failure, I guess you'd call it. So now let's look at it. The free body diagram is very similar, with the 100 pounds going straight down. The friction or the force applied is still 2 feet off the ground, but the normal force is going to be shifting from the center to the corner, because this is where if it's going to tip, that's where the force will be, because it's tipping and rotating around that point. Okay, and the friction force again is still acting from right to left, opposing the force applied. So what we're going to do here is we're going to do summation of moments, and we're going to do the summation of moments at the corner, because that's what the tipping is. The tipping is a moment being created at that corner and rotating it. And in this case, it would be a negative moment that would tip this in this case. So let's do the summation of the moments at C. And let's look at our forces. So we get 100 pounds, which is 1 foot over. That's a positive moment. And we have minus the force applied, which we don't know what it is yet, times 2. So it's 2 feet off the ground, okay, because that creates a negative moment. Now, we'll solve for that force, and we get 50 pounds. So in this scenario, the box will slide before it tips, because the 40 pounds for slipping is less than the 50 pounds for tipping. So it would never get to that point. It would just slide. All right, so now let's look at a case where it would tip. Okay, so one of the things we can do to investigate this is let's raise the force up. So instead of applying the force to the middle at 2 feet off the ground, let's apply it a little bit higher up. Okay, so give it a greater moment arm. So let's go 3 feet off. So at 3 feet, we'll do the summation again of the moments at C, and we get 100 times 1 foot, but now it's going to be minus the force times 3 feet. And set it equal to 0, and we get the force is equal to 33.33. So if you will apply the force higher up on the box, it will cause it to tip over in this case.